Hi, in this session we are going to learn how to test web applications with Rapise. I am Dennis, Principal Software Developer at Inflectra. If during or after this session you will have any questions, please use the chat window for this workshop. Let's talk about Web UI first. Let's learn more about the object we are going to explore. From perspective of a manual tester and from perspective of a test automation tool, web applications look very different. A manual tester sees the UI that you can see on the left side of this picture, while a test automation tool sees a tree of elements. I'll show what I mean. I'm going to open sample application, and this is how it looks from the perspective of a manual tester. What manual tester does is recognizes images, finds edit fields, enters text, clicks buttons, and the application looks very different if we are talking about a test automation tool. Let me launch the web spy in Rapise so we will see how a test automation tool looks at the application. Here it is. Here is our web spy. Let me track an element in the application. And here is what we see. The automation tool sees the application as a tree. This is a tree of elements, and each element has a well-defined structure. For example, our username input field is a node in this tree, and this node has a tag, and this tag is input, and this node has some attributes: class, ID, name, placeholder, type. So the list of those attributes can be different for different nodes, and those attributes have values. This is how an automation tool looks at the application. When an automation tool works with the application, it needs to solve a few common tasks. Let's look what task it must solve. First of all, identification of elements. Let's return to the web spy. To find the elements in this tree, by the way, this tree is named Document Object Model, DOM. To find elements in this tree, automation tool uses query languages. One of them is XPath. So you can see on the toolbar of the website an edit field where I can input XPath expression and I can test it. For example, to find this input field in the application, I need to write something like input. It has attribute name, and this attribute has value username. So hitting enter, and what I see in the test results pane is that this element was found. So I can right click this element, highlight, and I see it highlighted in the application. Another language that is used to find elements in the DOM tree is CSS. Let me enable CSS edit field. And if I will search for the input field using CSS, it will look something like input, name, username. Okay, found in this case as well. When an automation tool records a test and captures the elements, then it generates such selectors either using XPath or CSS. When we found the elements, what we need to do next? When element is found, we need to interact with this element. And there are different ways how we can send interaction events to the elements. First, we may send those events using browser-level events or DOM events. Those events are processed by browser from Firefox or Internet Explorer or Safari. Those events are very good, but they do not work always. Sometimes, because of some modern frameworks used by the application, there are cases when such browser level events are not working. And in this case, an automation tool should be able to send operating system level keyboard and mouse events to interact with the element. Let's look at this using one of the puzzles on the UI test automation playground. There are a couple of them devoted to this specific problem, the click puzzle and the text input. I will use the second one, text input. Here is the puzzle. So let's record a web test that enters the value into the field. And if this value is entered successfully, when we click on the button, the name of the button should change. Let's see how it works. I will close the SPI. I will cancel. Here I have an empty test, no objects, no steps, and I'm going to record my test. Starting recording from the toolbar, clicking on the edit field and enter some value for the button. Here it is, new name, and click on the button. Okay, we see that the name of the button has changed. Finishing recording, and here is my test with the steps. So it clicks on the edit field, enters the value, and clicks on the button. Let's reload the application and run our test. And we see that the test enters the value, clicks on the button, everything is okay. It was a click, but the name of the button didn't change. This is because that the application ignored browser level event and it just didn't work. When you see such a case during testing, then you can switch to using operating system level events to send a keyboard and mouse to the application. For example, to do this in Rapise, I need just to go to my steps and change do set text to do send keys and enter what I want to put into this edit field. Let's return to the application, reload it, and then run our test. And in this case, Rapise uses operating system level keyboard, and we see that the name of the button has changed. Okay, there are two types of events that we can send to the application, browser level and operating system level. One more thing that you usually do not notice when you are doing manual testing. What is easy for a human tester, wait for an application to complete some lengthy operation, or if application did not react to a button press, just hit the button again. This is what you even don't notice sometimes when you're doing manual testing. This may be a problem for a test automation tool, and in some cases, you need to insert steps into your test automation, into your test script to wait for application to complete something and maybe for specific object to appear on screen. For example, in Rapise, we have three ways how we can wait for something. On the line 4, you can see global do sleep. This is kind of unconditional wait. In this example, it waits 10 seconds and then proceeds with the next step. On the line 7, we have a global do wait for, which is given the ID of the object from the object tree. And here it means that regularly the Rapise will be checking for presence of this object. And if this object is on screen, then this test will proceed to the next steps. And if within a timeout period which is 10 seconds here, nothing appears, then test proceeds to the next step. And on the line 11, we see global do wait for property. This is the way to wait for a specific property of an object to receive a specific value. Let's see how it works. To demonstrate that, I'm returning to the list of puzzles, and there are 3 of them related to different delays. There is a load delay, which is for delay on the server side when server does not send a response for some time. There is Ajax data puzzle that we will be looking in more detail right now. And there is also client-side delay puzzle, which is about some lengthy calculations on the client side when application is not responsive. I'm going to Ajax data. So this is the puzzle that demonstrates that a request may be sent by the application to a server without page reloading, and the server may respond with a specific delay, and the application should be able to wait for something to appear on the screen. When I'm returning to my test, I will create a new sheet in my RVL. I will name it sync, and I will record a new scenario. So start recording, clicking on the button, and we see that a request was sent to a server. The server processes the request, and we have to wait until something will appear on screen. It should be here shortly. Here we see a green label with some text. I'm going to add a verification step that will check that we have this object and that its inner text has specific value. Okay, finishing recording. I will reload the application. Here I have my steps. If I will run them as is, playing this sheet, then the test will fail. This is because Rapise by default waits for an object to appear for some limited time, which is configurable, by the way. And if the object is not found, then we have a failure in the report. If you want to change their default time, Rapise waits for an object, you can go to test settings, and you can change the number of lookup attempts, and you can change the interval between those attempts. Current settings say that Rapise will be waiting approximately 9 seconds for object to appear. In some specific cases, we want to add a synchronization waiting step. I will add it here. I will use global object that has do wait for action, and I will use the object that we recorded. By default, it will wait for 10 seconds, and I can change the default. Let's set 30 seconds. Okay, let's reload the application. And I will, okay, not play, but play this sheet. Okay, it will hit the button. And immediately when the element will appear on the screen, the script should proceed. So we have a 30 seconds timeout. Okay, we see that Rapise found the label, and the data in the label was exactly as we expected. So we are able to find elements using XPath and CSS. We are able to interact with them using DOM and OS level events, and we are able to wait for application to load and initialize data. Now we are ready to make a test. And there are 2 ways how we can create a test. The first way is recording, and we did it several times. Okay, I'm going to create a new test at this point. Let's name it sample demo up 2. It will be a web test. I will use Firefox and I will use RVL. And I'm going to record the test with a sample application. Go into Home. Here is the sample application. And I will record my test. During recording, objects are added to the object tree and selectors for those objects are generated automatically. Rapise does a lot of things for us. Let's enter username, password, login, logout, finish. Okay. This is a recorded test. Here in the object tree, we have all the objects. If we go to object properties, we can see the selector, and also we have the steps. This is one of the ways how we can create a test. The second way how we can do this is we can use scripting language and we can program everything by hand. We just may ignore all the recording functionality and do everything by writing code. For example, we can define a variable with username selector, and we know that it is input. We can determine this selector by using WebSpy or by somehow analyzing the application using built-in browser tools. Username. Here is the selector. Then we may find this username by using navigator find, and we may pass username selector to this find, and then when we have the element, we may do click. Everything was programmed by hand in this case. This is also possible. When we have a test, it's time to execute this test. And there are different ways how we can execute those tests. Let me proceed to execution types. There are two ways how we can execute them. There is a headed execution. This is the way when we execute our test. I don't want to execute just the JavaScript part I created. Let's play. And the test is executed using the browser. Okay, works. If I want to execute it using another browser in headed mode where we can see what is happening, I may select the browser here, play it again, and Rapise should open the browser. Headed mode is a good way to see how the test works and troubleshoot something. If something goes wrong, you immediately see what is happening. The second way how you can execute your test is headless execution. Headless execution means that UI of the browser will not be displayed on the screen. I have configured headless execution in Rapise. For example, let's choose Chrome headless execution. To do headless execution, Rapise uses Selenium integration. And if you want to find out how to configure headless execution in Rapise, you can go to Rapise knowledge base, do a search for headless, and you will see two articles. One of them explains how to configure headless for Chrome, and another for Firefox. I selected Chrome headless, hit and play. We see that test is executed and we don't see browser UI. Headless execution is good when you want to run your tests and you want to do something else on the machine, because headless execution does not interfere with your keyboard and mouse. Okay, and there is also remote execution. Remote means that we can execute our test not only on a local machine, but on machines that are available in the corporate network or some farms on the network that provide access to different versions of browsers. For example, here I have configured the link to Safari, which is obviously running on some Mac machine or on my network, to see what is happening there, because we don't see the Mac machine in the session. I am going to enable screenshots. So I go to settings of Rapise and set capture execution screenshots. Okay, well, let's look at the profile for Safari testing. Here is the URL and some settings for Safari. Hit and play. You don't see the execution. It is somewhere on another machine, but screenshots are on, and we'll see what was happening there in a minute. So we can see in the execution monitor the steps. Everything was okay, execution was successful. And here is the screen flow page generated by Rapise. We see the screenshots from Mac machine. Here is how our test was executed. We have a test, we can execute it in different modes, on local machine, on remote machine, in headed or headless mode. And this is just the beginning of the journey. So when our test is ready, there are high chances that at some point in the future, this test will be broken and we will have to fix it. Now we'll be talking about maintenance of tests. And there are many reasons why a test may become broken. Most frequent reasons are developers update the application, something is changing in the layout, and some fields disappear, some fields are added, buttons renamed, and this influences test execution. Also, browser vendors update their browsers, and in rare cases, but sometimes it may also break test execution, and even updates to operating system may also break execution. When tests are broken, we obviously need some tools that should make fixing the test an easy and quick task. Rapise has many of such tools, and I'll show how they work right now. I will create one more test where I won't be fixing the locators of elements. Okay, let's create one more. Sample app demo 3 will be web, Firefox. Okay, the test is created. Here is the application. I will start recording. Very quickly, I will get the test. Clicking, user, password, login, logout, finish. Okay, I have a test, and if I will execute it right now, it will work without any issues. We see username, password entered. Okay, test is working. Now I will go to the browser and will simply reload the application. Returning to Rapise, hit and play. And we see that the test does not work, and we'll try to figure out why. We see that the test did not find username object. So one of the most frequent reasons when test gets broken is when it just cannot find some object in the application. Okay, we'll try to fix the test. First tool we can use to examine the application is we can use Flash. I am expanding the object tree, finding the object where the test failed, right-clicking this object and choosing Flash. Flash just tests the selector of the object, and if it works, the object will be highlighted. If not, we will see a message like this. Object is not found, so obviously our selector doesn't work. Look at the selector. I am choosing the object in the object tree, go into its properties, and I see that this selector is searching for input field that has name username and that has ID like this. Let's start recording again and learn this object once again to see what selector will be generated. Returning to my test. I don't need this step. Here we have username 1. And if we look at the username we had before, it had this ID, which starts with 0E. And if we look at username 1, it has different ID. Okay. This is because this ID is dynamic, and every time we load the application, this ID is different. Okay. We can fix this test very quickly by using relearn. What relearn does is, so let me remove this username. I can choose relearn, and it will recapture the selector for the object. I will click it here. The selector will be rebuilt by the tool. If I will use Flash at this point, then the object will be highlighted successfully. But next time when the application will be reloaded, it won't be found again. So we have a selector which is not resilient and it doesn't survive when the application is reloaded. There are two ways how we can cope with this problem. We can go here and just remove this part, or we can create a web application profile. Web application profile is a pretty big and important topic, and it deserves a separate session, so it will be covered tomorrow in the advanced topics track. Another tool that I will leave for tomorrow is self-healing locators. And of course, the last tool that can be used is a web spy. I showed it at the beginning of the demo. This is the tool that helps you to examine the application. Here it is. You can analyze the DOM tree. You can look at the properties of the elements, and you can just see if their objects from a specific window can be found in the application. Here in the right side of the web spy, we have the object tree. If I will double click on the window and the element is found on the page, then it has this green check mark. If element is not found, we see this unhappy face, and we can actually fix the locator right in the spy. So we can build the locator, which is good, and always finds the element. It will be username. Okay, so we found the element. Here it is. And I can use relearn username, and it just updates the selector of this element. I can do this multiple times and fix all the objects on the page. Thanks for watching. I am Dennis from Team Rapise at Inflectra. Thank you for joining me today.